All right, hello. How's everyone doing today? Excellent, I'll take excellent. Welcome to reInvent 22. This is actually my first time here, which is super exciting. There's so much energy. Anyone else, first time here? A few, wow, okay. Anyone else here for the second time? Okay. Third time? Okay, wow, all right. Welcome. So my name's Andrew. I'm a product manager here at AWS, and I'm joined today with Prarthana.
I'm Prarthana. I'm a software development manager in AWS.
Yeah, and we're here to talk about optimizing price and performance with Amazon EBS. So I hope you're in the right place. So we're going to start with an overview of the storage options in AWS. There's quite a few. And then we'll move on to EBS specifically. We'll talk about the portfolio, what options are there, and how you can think about optimizing. And we'll talk about some customer examples where they've taken a workload, an app, and they found ways to save cost or improve performance. And then I'll hand it off to Prarthana, and she'll talk in detail around different workloads and apps. So in AWS, we have object store, we have file storage, and there's block. And those are the three primary storage types. And around those, we have data services, and we have hybrid and edge, but we're not going to talk about those today. And with object store and file, you access the data through a protocol that uses metadata. And so when you access block, the difference is that you go directly to the data. It's the ones and zeros. It's very fast. It's very performant. And so object store is a great place to put data that you're going to be using for things like mobile apps, data that is going to not change very often, or to build data lakes. It's a great place to do that. In file store, there's a lot of options there. It's everything from scale out. If we wanted everyone here to have access to the same files, that'd be a great place to start. But we're going to talk about block today. And if you're not familiar, block, it's everywhere. In fact, it's in your pocket if you have a phone there. It's in my watch. Block is really a ubiquitous storage type. In fact, file and object are built using block. So it's pretty cool. It's the center of the slide. It's the center of the storage universe, right? And so we're going to go into detail here of what is Amazon EBS. So we know block storage is performant. And so what is EBS? So EBS is an easy-to-use, secure, high-performance block storage service. So instead of managing the hardware, you think of, with EBS, things like volumes. It's a logical device instead of a physical device. And you use it with EC2. So, in fact, if you use EC2, you already use EBS. So is anyone here familiar with EC2? Use EC2? A few, okay. Yeah, so you already use EBS, it's great. There's two main types of EBS that we should talk about. The first is instance store. And this is just like your phone storage. It's physical storage attached to the EC2 instance. And so it's not separable. If the instance goes away, the storage goes away. If you terminate it, the instance, the storage is gone. And then there's network attached EBS. And that's what we're going to talk about here. And with network attached EBS, it's built on a massively distributed storage system. And so this lets you get a lot of performance, the block storage performance you expect, but also your storage lives outside of the instance lifecycle. So you can move the storage around, you can switch instance types, and you still have access to your block storage. And so we're going to focus on the network-attached EBS today, the managed volumes. And in there, we have two main families that we're going to talk about. And one is SSD-backed, so you can expect performance you would get from an SSD device. And the other is HDD. And this will give you the price performance of the HDD hardware. And both of these are flexible. You can use elastic volumes, data services to switch between types, switch performance characteristics. You can create these via the API, SDK, the management console. And there are backups that are available. You can take snapshots that go to S3 if you have data retention policies that you need, or you want to have the data available later. And so I'm going to take a second here. There's a ton of stuff we've done since we launched in 2008. But here we're gonna talk about a few key ones that relate to optimizing price and performance. And so in 2008 we launched with standard and snapshots. And standard is our first volume type. It was an HDD volume type. It offered 100 input-output operations per second. So that's what we call IOPS, and that really is a measure of performance. And so 100 IOPS, and they were best effort IOPS. So sometimes you might not get them. And so that was where we started. And so in 2012, we launched our first SSD volume type. And this was called provisioned IOPS. And we chose the name to be very descriptive, so you can provision IOPS separate from storage. But also, you're not getting best effort IOPS, you're getting provisioned IOPS. So you're gonna get the performance you expect from those IOPS. And along with that, we actually updated the EC2. So keep in mind, when we're thinking about optimizing EBS, you also wanna think about EC2, because the relationship there is tightly coupled. And so with EBS optimized, what we did is we gave a dedicated network attachment for EBS. So you can separate your storage network from your EC2 front-end network. And you can, something we'll talk about, again, I'll talk about and Parthan will talk about a little bit later. And so now we have standard, spinning disk, price performance of spinning disk. And we have provisioned IOPS SSD, which is SSD that you can provision performance. It's really reliable. It's a great volume type. In 2014, we did a general purpose type. And again, this, the naming is, we're trying to be very descriptive here. It works for the majority of workloads. And we see the majority of customers start here. This is where you should start. Gives a balanced performance of the SSD portfolio. Gives you the low latency, single-digit millisecond of SSD at a price point that is between the HDD and the provisioned IOPS. And so now we have the SSD family, 2 volume types, so you can choose which one works for your workload. And then in 2016, we had a new generation of HDD. And this was really focused on streaming and throughput workloads. So if the SSDs are really good at IOPS, streaming and HDD workloads are really good at throughput. And so there are 2 types here. One, SC1, that is for colder storage, infrequently accessed storage. And ST1, which is great for streaming workloads, transcoding workloads, things like that. And so now, if we step back, we have 2 families, SSD, HDD. We have 2 types. So you can really find the performance and the volume type you need for your workload. And what we heard from customers is that you know, you want a simple way to move between those types, or even scale those volumes. If you need more storage, you don't want to have to recreate your instance, right? And so we came up with elastic volumes, and this lets you do just that. I've heard it described as the feature that gives you your weekends back. I think when I was an engineer before I came into product, if we had to get a new storage device or new compute in our closet, we had to take the weekend off, right? You had to have downtime. Well, elastic volumes gets rid of all of that. And so you can change the size, increase it. You can increase or decrease the performance. And you can switch between types seamlessly. And so one use case for this is if you have, say, end of the month reporting that you need to do, needs to be done in a short amount of time, you can switch from, say, the general purpose that works for the majority of the time, provisioned IOPS, and get the higher performance that you need for the end of month. And so that's the state of EBS 2017. And in 2018, we launched Data Lifecycle Manager. And this simplifies how you think about snapshots in your backup strategy. So you can set schedules on creating and retention of snapshots. And we'll talk a little bit more about how this helps save cost and optimize performance. And then in 2020 and 2021, we launched a next generation of the SSD family. And so we have GP3, which takes what customers have told us they liked about provisioned IOPS, and you can provision performance separately from storage, so you can right size. And then we launched i2 Block Express, which is incredibly performance. It has incredibly low latency. It's sub-millisecond latency. And it can scale up to 256,000 IOPS. So if you think back from i2 Block Express from standard, you had 100 best effort. And EBS has gotten to the point now where you have 256,000 provisioned IOPS. And so it's come a long way in this time. And the last thing I'll mention on this slide, kind of set the stage for what we're going to talk about with optimization, is Snapshot Archive. And so now we have a second tier of Snapshot that's lower priced than the standard Snapshot. And so this lets you, meet the price performance needs of your workload. If you have, say, snapshots that you won't access, but you need to have for a governance policy or for compliance reasons. So you can put it in like in S3, colder storage, lower cost, infrequently accessed, and save cost doing that. And so just to summarize, so we have instance storage, which lives with the instance. It's not network attached, it's direct attached. Then we have EBS volumes. That's where we have this portfolio of two volume families. We have snapshots. We have data services on top of that. And so this is what we're talking about today. And this is what we're going to be talking about optimizing price and performance. And so millions of customers use EBS today, and they create millions of volumes every day. And we looked into this as trillions of I/O per day, which I'm not even sure off the top of my head how many zeros that is. It's a lot of I/O. And so we learn from customers when you use it. We talk with you. We love to hear how you optimize price performance, how you use EBS, how we can do better. And so I want to share two examples where customers have found ways to save costs, improve performance, improve scaling, and really get the most out of their EBS in the cloud. So the first example, it comes from a large matchmaking service company based out of India. And they have millions of users daily. And they, like many other companies in 2020, were faced with a surprising scale, right? They had, I think in one week, they had 57% increase in user signups. And so they had to scale quickly, and they did. They used CloudFormation templates and auto-scaling groups, and anytime their traffic would hit certain thresholds, they would add nodes to their backend database, excuse me. And so they were able to meet the needs when they were scaling at 57%. After that fact, they talked with their AWS team, their account team, and software architects. And they dove a little bit deeper on, how could they improve the speed when they scale, and how could they improve the price? Because what they were doing is they were adding instances, entire copies of the database. And so when they dove in, the first thing they would do is understand their workload. So what were the bottlenecks in their workload? And so they were using R5 8XLs, and they had EBS general purpose volumes. And they had about 6,000 IOPS per instance. And so that's what they thought they needed. And they were looking at their CloudWatch metrics, and they saw CPU utilization was high, and that's how they made the decision to scale out. When they looked at it, the reason the CPU utilization was high is that the EBS volumes were actually the bottleneck. They needed more than 6,000 IOPS. And so they did some testing, and they found that the R5 8XL actually has more than 6,000 IOPS on that EBS optimized bandwidth. And so when they scaled up the IOPS, they got the CPU, headroom, they could take more traffic, and so what they found is that they could scale up their EBS when they had new user registration, when they had any, if they had new matchmaking traffic. They could scale EBS independently, so they didn't have to add nodes. That saved them quite a bit of, I think, 27% of total cost when they were scaling. And so they put that into effect, and then in 2021, when the lockdowns continued, and they saw another scaling event, they were able to save, it was 27% in that second scaling event. So that's a great example of how you understand your workload, you understand what the bottlenecks are, you choose the right volume type, and moving to the newest generation volume type is usually a great way to start there. And then using elastic volumes to make that transition, do it automatically, and if you're doing it at scale, you can schedule it and keep your weekends, right? So the second one I want to talk about is with snapshots. And with snapshots, Johnson & Johnson, they are one of the largest healthcare companies in the world. And they're a big user of workspaces. They're a fan. If you don't know AWS Workspaces, it's a cloud desktop. It's backed by EBS, and it uses, it lets you spin up desktops for your employees. And so Johnson & Johnson had, I think it was 43,000 workspaces. And because of compliance reasons, they need to actually keep snapshots, those desktops. If you close it off, shut it down, they need to keep a snapshot so later they can go back and look at what was on that desktop. And so they were taking hundreds of thousands of snapshots. And when we launched Snapshot tier, Archive tier in 2021, they took a very close look and found that they could move a significant portion, petabytes of their snapshots from the standard tier to the archive tier, which is a very great way to improve the price of your snapshot and your backup. And they followed the same pattern. Their use case, they didn't need these snapshots available immediately. They weren't making a copy across regions. They were making a copy for disaster recovery. They were doing it for compliance. And so it was really, what is the lowest cost that I can get, have my data available to me eventually to meet my workload need. So they knew their workload. They looked at what options were available, and they made a change, and they moved all of their snapshots they could that were for a retention policy over to the archive tier using AWS Lambda. So very simple process. Great example of thinking about your workload, knowing what you need, and choosing among our portfolio. And so I'm going to hand it off to Parthana here, and she's going to talk a little bit more about workloads and the portfolio. Thank you.
All right. So Andrew actually has introduced a lot of concepts where I will dive a little deeper into those, giving you some examples and talking about specific workloads that you guys might need to use. A lot of the concepts that Andrew has introduced to you already talks about how performance is optimized, how cost is optimized. I'll try and dive deeper into what your workloads need, how you can establish a connection between your performance and your cost optimization that you're looking for. All right. So as I mentioned, Andrew introduced the different volume types here. I quickly want to recap. We have two categories, two families of volume type that EBS supports. One largely is our hard drive backed products, and other is our SSD backed products. In the SSD backed products, now at a very high level, right off the bat I want to mention our SSD backed products are where you go to for most of your workloads. As you will see in the subsequent slides as I talk through those, most of what you need will be satisfied by our SSD backed products. There are obviously some difference between the two. I'll talk through those as well. First, in our SSD side, we have general purpose volume. again, Andrew mentioned that, introduced that already. We have our GP3, which is actually, it fits most of, 70 to 80% of any workloads that you can think of. The one reason why we call it the general purpose volume. The next volume type in our SSD backed family is the IO2, which is backed by our Block Express architecture. Now the Block Express architecture, the architectural changes that we have done in our, that is backed by in the IO2 volume type right now. I am not going to go into the details of that architectural changes. There are deep dive sessions that will be happening. I think one is tomorrow and one is Thursday. If you are interested in those architectural changes, I really think those are the sessions that we will go deep into. But for now, just mentioning IO2 backed by Block Express gives you a better performance, actually 4 times better than GP3 volume. One thing to note here is IO2 is also the most expensive. So you have to think about what you are going to do that. I'll talk about the workloads that could be good for your IO2 volumes as well. In our HHD backed product family, we have our ST1, which is our throughput optimized volume type. Here in terms of performance, when we talk about performance, we are not talking about the latency. We are only talking about throughput in megabytes per second. So when we design the ST1, we are focusing on the performance in terms of its throughput, not in terms of its latency. Our SC1, we often call it our cold hard drive backed product, has very similar characteristics as ST1, but the performance is slightly colder, which is why we also called it the cold hard drive backed product. Very quickly mentioning, SC1 is also the cheapest of the volume type that you will find. Diving a little bit deeper into the characteristics of our volume type, we start with GP3. So the IOPS has a baseline of 3000 and a throughput baseline of 128 megabytes per second, which means you start with that. And you can extend the IOPS to 16,000 IOPS and throughput to 1000 megabytes per second. Both the extension up to 16,000 and 1000 megabytes per second comes with a cost. However, you don't have to provision any extra capacity. You start out with say 1 gigabyte and you can go up to increase only the performance characteristics without having the need to increase your volume size. So that is what we brought with GP3, that you can increase your performance, you can customize your performance requirements based on your workload without having to focus on increasing your capacity. It comes with a single digit millisecond latency. So if you are running your intense workloads, database workloads, all your critical applications that you require to work faster, works great. As I mentioned, capacity increases and the IO size goes up to 256 KB for the logical merge. Now what do we mean by logical merge? If a IO comes in, we don't hold on to it to complete it. We just let it go, and the next one when it comes if we see that it is the same IO or it is in the next sequence, it logically fits into the next sequence, this together is counted as one IO. You can do a one full LBA range scan per several times a day actually with this volume type. Now why do we call it the most general purpose? Because it is used for any volume type. You can use it for your boot volumes, your very intense applications that require very low latencies, and the bursty databases also works great. It's truly general purpose. If you don't know where to start, I highly recommend that you start with GP3. One consideration is, actually I'll talk about how you can, if you have chosen a volume type and you want to change, Andrew introduced that as well, but I'll go into that in a little bit. But I highly recommend that if you have not used EBS volume type, start with general purpose, start with your GP3. You will be you will see that you might not even have to change it at all. It's satisfied almost 80% of the workload. This is our volume type, the IO2 backed by our Block Express architecture. This was actually announced as a preview last reInvent. Those of you who are here for the second time, I was here when this was introduced, very exciting time. So the next generation of architecture, as I mentioned, we will go deeper into those architectural changes in deep dive sessions. But I do want to mention that we have actually spent a lot of years thinking about how we are going to optimize our design. We have come up with a new storage fabric which is backed by the SRD networking protocol that AWS introduced a few years back. I'm not sure if you guys are familiar with the SRD networking protocol. It actually serves much better than TCP in scenarios where there is a failure and there is a contention and all of that. So the new architecture is backed by our the AWS's SRD networking protocol. That SRD networking protocol is scalable, reliable datagram. If you're not familiar, I think most of us are familiar. It was announced, I think, 4 or 5 years back. Yeah. And we have also actually thought through what our hardware designs should be that will give us the best performance. I can truly say the IO2 backed by Block Express architecture provides the best performance of any volume type ever that we have introduced. It comes with a price, of course. Actually, the performance characteristics are 4 times better than our previous generations of volumes. And it also, you can also provision your capacity up to 64 terabytes per volume, which is also 4 times what you could do with GP3 or any other volume type. The most interesting and the most exciting part of the IO2 volume, which is backed by the Block Express architecture, is the latency. It comes at a sub-millisecond latency. So you think about how much this works for those critical applications which you don't want to, you don't want your users to wait for login or any such very critical applications that there are. IO2 Block Express is the ideal one. Actually, a lot of our customers have onboarded since we released IO2 with Block Express, backed by Block Express architecture, generally available earlier this year, I believe. It was announced as preview last reInvent and it was generally available earlier this year. A lot of our customers have already been using, and we have been getting great reviews particularly about the latency improvements that we have made. I'm truly proud of the volume type that we have. Now we have talked about those characteristics, right? How do you know which one you want to choose? You have GP3, and then we have some very interesting and very good improvements that we have already made with IO2 backed by Block Express. Now which one are you going to choose? It's really important that your applications have the monitoring built in. And I think we don't run applications without having monitoring. Once you are able to pick and choose what your application requires and then match with the characteristics that the volume types have, that is what you should go to. That is what your best optimization technique is. We build the monitoring and we can clearly see that, hey, I have provisioned IO2 Block Express, but I don't really need that. I can move to GP3. Andrew talked about moving it using the elastic volume feature, and that's very seamless, very easy to do, and then you don't pay as much as IO2 Block Express. You just have to choose the correct volume type based on your requirements of performance, your capacity and all of that, and you can get all of this by building that monitoring on your applications. I go back to making sure you choose the right volume for the right workload. And when we do that, there are several questions that you answer. it's your applications, you will know what it requires. So these are just a sampling of questions, no means exhaustive. You can like think about what kind of instance you're using, what is the best volume type that you will be needing for that, what are your latency requirements. One of the most important questions that I think we need to answer for our applications, what am I going to use it for? Is it really customer impacting? Is it my logging database? What exactly is it? Now, I just put together some of the questions that you could think about, but really it's very workload dependent. I wouldn't know any more than you do about your workload. So definitely try and think what the questions you want to answer before you choose your volume type. I'm stressing this over and over again because the best thing you can do to optimize the performance and price for your block storage that you provision is actually choosing the right volume type. That is why we keep saying that, hey, make sure you know what you're using it for, make sure you build your monitoring, tweak your performance requirements and all of that. So we talked about our SSD back product. Now I'll move on to a little bit about our hard drive back product. I mentioned this before. It's throughput optimized, not latency, not IOPS optimized. When we think about performance, we think about throughput here. It comes with a baseline performance of 40 megabytes per second, and you can go up to 500 megabytes per second. There is a burst, and it supports up to 500 megabytes per second on that as well. Capacity can range from 125 to 16 terabyte, 125 gigabytes to up to 16 terabyte. And IO size, I talked about logical merge, that happens for about 1 megabyte. I would suggest not using this for your boot volumes. It's not really good for your boot volumes, but you can use it for your very large block storage requirements where throughput is very important. You can use it for your sequential workloads like say logging or any monitoring that you might want to store. The throughput optimized volume type, we don't recommend that to use that for your very critical, customer impacting workloads. It comes at a price which is like very optimized already. So if your workloads fit this volume type, a great volume type we suggest. Moving on to SC1, if you look at the volume characteristics, it is very similar to what I just mentioned for ST1. It is just a little bit more colder, but it is also very cost optimized. This is actually our lowest price volume type that we have in our portfolio. And in SC1, you're trading the performance for cost. So you're saving cost, but you're not getting as optimized performance as you're getting with the other volume type. This is also very good for your sequential workloads such as logging, or maybe you're backing up your workload. You don't need it's not very critical. You can use SC1 and you save on the cost for that. One of the questions that we left out from that list of the questions that we answered is what you have here. If you are saying yes to this question, your applications are mission critical. It is a tier 1 application. It is a customer blocking, impacting application. So you would want to use the volume type that we talked about, which supports our mission critical applications. So this is one of the most important questions that you could ask. We move on. I talked about all the volume types. Now I move on to the workload, so that we can find what exactly what exact workloads will fit what kind of volume types again. Though we talked about that while defining the volume types as well. Now, all applications that you have are actually customized to your customer facing workload or whatever your workload is. So it could be one of them or it could be a combination of them. So what I want to mention here is you don't really need to have only one volume type in your portfolio. It's okay to have a SC1 and a GP3 or maybe an ST1 and a IO2 block express. So we can pick and choose. The workloads are very diverse. So of course our volume portfolio that you have, that you start building up, that you provision, needs to be diverse as well to support all of these different types of workloads. Diving a little bit more deeper into some of the volume type, some of the workloads. Before I go there, I just wanted to mention not all workloads will fit into that nice and neat little boxes. So we should not expect that, hey, I have only one requirement, so only GP3 is going to work. You don't even start thinking about only one volume type and match to that. I will walk you through some of the important workloads and you might see that, oh, this works for GP3 and IO2 and it might work for my ST1 or SC1 as well. So it's okay to not have only one volume type or try and fit it into one neat box. Every applications, I don't want to say every, but almost every application has a database behind it. There is some sort of persistent storage that you are using, whether it is a SQL based or no SQL based. These database requirements are usually what drives the performance requirements for your application. Databases usually have random I/O. We can't predict exactly how we can, but even if we can predict it, it usually does not go in one straight line. I/O usually goes up and down with the usage. Every database, whether it is a SQL or a NoSQL database, has some sort of logging or a journal where you are keeping the state of the data in storage. So as I mentioned, even while you are using a database application, there is a write-ahead log that you need to account for. Mostly, it is very, very workload dependent. If your customers are coming in and trying and doing one sort of activity in the morning and they do something else during the day, your database workload requirements will change with that. We suggest you use the SSD backed products for this, mostly because of the performance requirements. Whether you want to choose a GP3, an IO2 block express, we recommend you choose the SSD backed product. We have seen that there is a lot of VDI applications that are getting, that are using, a lot of customers who use the VDI applications now have our EBS backed storage behind them. Now for your VDI applications, again it's highly workload dependent. You might see a login storm come in. You might also have to account for the boot, that planned boot that needs to happen. And you also have to think about the time of the day when in the morning everybody comes in, logs into their virtual desktop. So the login storm is something which is latency sensitive and you need to account for that. The I/O is mostly random. We suggest our SSD backed products. Actually, GP3 works great in this kind of situation. So our recommendation would be using GP3. Any SSD backed product actually from the portfolio. So media is one other type of workload that a lot of our customers are using. Here we are mostly talking about transcoding or encoding, actually any streaming workloads that we have. These are typically very high throughput requirements. They have very high throughput requirements, And they have mostly sequential I/O. Latency is not often a consideration here, but the throughput requirements are the top priority. The sequential I/O is also often sustained throughout the period of the application life cycle. Here, we are recommending using our ST1 back product, which is throughput optimized. So it is going to be optimized for this media workload. Moving on to the next type of workload, which is our data and analytics. I'm pretty sure most of us are familiar with this. It again has very high throughput requirement and sequential I/O. The difference here is that there is a periodicity to it. I'm calling out daily periodicity. It could be weekly, it could be monthly. Essentially, you're not accessing the data of the disk all through the day. It is mostly you have some kind of periodicity to it. So for this kind of workloads, again, high throughput, so we recommend our HHD backed products. Depending on if you are okay with the cold performance of SC1, or if you would like it to be a little bit more optimized, go with the ST1. But HDD products work really well with this kind of workloads. File storage is another very common application, the CIFS, NFS, even archiving. This also has not very high throughput requirements. The workloads are bursty, but even when the workloads are bursty, we have seen that most of our customers have workloads where the application is not a sustained access pattern. We have not seen a lot of sustained access pattern here. There's not a lot of traffic in this kind of workloads. For this workload, the cost sensitive option of SC1 works really well. Now what you're doing here is you're saying that yes, I am going to archive my files, I don't need to access it very often, and even if the database is bursty, we don't have a lot of traffic to it. So you don't need to pay too much for it. So go for the most cost optimized option here. I wanted to talk a little bit about containerized workloads, though this is not a kind of application. Any kind of application that are running in containers, which we are seeing a lot of our customers are doing that. So a containerized workloads, I'm giving an example of Kubernetes here. We see that you can specify the volume type on your workloads. You can specify your data, latency performance requirements, scale, and manage the workloads using the CSI driver. Now, what exactly is a CSI driver? So the EBS CSI driver was launched in 2021 April. It went GA. It's an open source product that we developed. It's very easy to do all of your persistent, all of your block storage requirement, access all of your block storage features that we talked about so far using the CSI driver. It's also an open source product, so very, very easy to give us requirements or go ahead and make changes. These are all very community driven. Now, why am I talking about containerized workloads? Earlier, we used to think we as in EBS, we used to see that all the applications that are running in containers are usually very ephemeral. They would shut down the application without caring about the data behind it or persisting a storage behind it. In the last few years, we have seen a shift. A lot of our customers, a lot of our existing customers are now running their applications in containers. They want to keep the state of the application when they shut down the container, or they want to persist the data that the applications use. For example, the developer tools like Jira, Jenkins, I think a lot of us in this industry are very familiar with those tools. the developer tools, those needs the states to be maintained. So you don't want your application to lose its states when it is shut down. Same with web content management like WordPress, Drupal. Here also we see that the developers want their state to be maintained. So we provide that option with EBS storage, block, any block storage, and you can access all of that using the CSI driver. In fact, within the CSI driver, you can provision the block storage with your volume type defined, with your performance requirements defined. One other very common applications that we see our customers use in containers are the shared data sets. There are the machine learning models that are getting built, and from that same data set, there are some data science tools and models which we want to persist, which they want to persist, and they use their block storage to persist that kind of data as well. As I mentioned, we have, you can do all of that. You can provision your volume type, you can manage, including the lifecycle management of the volume using the CSI driver. And it is if you are running your applications in Kubernetes clusters, in using Elastic Kubernetes service, using EKS, our AWS EKS service, then it's a one click. There is an add-on option in your console, and you can choose to install the CSI driver using the add-on option. If you are using Kubernetes in AWS without EKS, if your Kubernetes cluster is self-managed, you can do that using updating your Helm charts and running the kubectl command. I just put a screenshot of my terminal, and it's just a single command that you use, and you will be getting CSI driver installed to use with your clusters. Now, we talked about a lot of application patterns. We talked about a lot of our volume types. I want to reiterate, I know I mentioned this once, but even if you take 5 different volume types, there is absolutely no reason why you should use all volume types need to be of the same performance characteristics, or even the type can be different. You have an EC2 instance, you can attach multiple block storage, multiple EBS volumes to it, but you can also pick and choose. You might choose 2 SSD back product, the rest of the 3 HHD will work. So definitely leverage the elastic volume feature that we have, very easy to use. You can customize your performance requirements. You can change your volume type all very easily without any interruption to your services. This is one of the best way to actually optimize the performance and price. When we talk to our customers and they ask us this question, the first thing we in EBS look for is if they have the right set of volume and the performance characteristics that they could use for their applications. Now, what does that mean? It means that even the volumes that you have chosen, you think that I'm not using all the performance characteristics that I have provisioned for and that I am paying for. It's okay to dial down, and it's seamless. There is no interruption to your application at all. So definitely Elastic Volume, one of our best tools to optimize price and performance. Now, what did we talk about? We are of course coming towards the end of the session. I want you to remember that we are continuing to work towards lowering our cost. Cost sensitivity is very close to EBS. Whatever we build, whatever we focus on, we keep in mind that we want to provide all of these great features, all of these capabilities to our customers with the best cost, at the best cost possible for us. The performance and reliability we talked about, EBS provides 5 nines of availability promise, and the performance, also we talked about the different performance characteristics of the volume type. It's very reliable. What do we mean by reliable? Your data is available to you when you need it, and we have a service up guarantees. So we are always thinking about how to make that available to our customers. We have talked about a few tools. Mostly, I think both of us talked about elastic volumes. There are the storage tier for Snapshot. There are DLM, the data lifecycle manager. Multiple tools we have built. We continue to build so that you can scale your storage requirements, and you can also manage the entire lifecycle of your volume requirements. We continue to innovate in this in the tool area, providing you the best features and tools to use with your volumes. Best of all, we are making everything very simple for our customers to use. You can use EBS volumes, all of its features, with all the tools and capabilities that you are very familiar and comfortable with, whether it is the SDK, the CLI, the console, all of that. One aspect that I want to bring up, which we have not talked about yet, is our security. EBS prioritizes security first. Anything we do, any new work that we pick up, we are constantly putting security as our first requirement. The volumes are backed by I keep forgetting, 256 AE, 256 encryption, and we are backed by our key management service infrastructure, the KMS encryption infrastructure. So your data is encrypted at rest, in motion, and the snapshots. So definitely use the encryption. It's extremely important to make sure that your volumes are secured. We ourselves put security first, and a lot of our features, a lot of our efforts usually go into making sure that the features that we are building is secure. We talked so much today, so many different things we have provided, options we have provided here. It's very hard to remember all of this that we have talked about in a whole hour. So, leverage the learnings that you get available. This mostly are free, very easy to go through. Definitely leverage our storage options. This is the first I think this is the first EBS session that we have in reInvent. There are multiple more that we will have. If you have something you want to dive deeper, if there is any particular area of interest for you, I encourage you to please go and attend this. We also have a storage booth where you might want to ask questions. So we are towards the end. Thank you a lot for being here. Andrew and I can take questions, or we can walk to the back, or if you have any questions for us, happy to answer. Thank you for being here.